So yeah, I had the unfortunate occurrence in which I did manage to fall under a DLR train a couple of years ago now, 6 years. And it started me on this journey, which kind of made me challenge the way in which I was building my human body and what I could build my human body of with this kind of new blank canvas. And in a kind of weird turn of events, I got the chance to build my own arm. And it was funded by a video game company called Konami. And they were launching a video game called Metal Gear Solid 5, which some of you probably heard about. But it was really cool because I got to design my arm and choose features of it that expanded my human abilities in different ways to normal. But because of my amputation height, it's really difficult to sort of integrate with technology. So I thought of different ways to have more stuff. I lit it up with loads of LEDs that I could plug into my laptop and code the colors and basically choose my outfit for the day, which is fun. It had Twitter connectivity. It had a drone on the side, because why not have a drone if you're thinking about sort of expanding your human experience? I had these goggles which I could wear, which I would see through the drone and sort of have an external body part that went into the world and saw things in a different way. But it wasn't very effective, really, because we chose to have this prototype hand on the end, which was a fun experience as well, working with 3D printing and sort of challenging the existing hardware and technology that was commercially available. But it basically broke because it was a prototype. It was the first time we ever built it. We just built it and put it out there into the world. So I'm kind of here to explain why would you want a metal hand? It's like a question, really. And these are the things that you have around today, the commercial hands that exist. And they look kind of cool because they have this kind of pentadactyl, the 5-digit limb, which we're all used to. But really, it's not as flexible as a human hand. Because obviously, when I'm holding this clicker, for example, I'm grasping it in a number of flexible ways, and I can like manipulate it in my hand and control the splitting of my fingers, the movement of my fingers. But these hands are quite, they're kind of robotic and very simple. They're kind of monkey robotics, because they have these pinch grips, cylindrical grips, and they have programmed grip patterns. And you basically activate them with 2 muscle signals. So you have the ability to open and close a grip pattern, but it's kind of preset. It's not feeding back to you. It's something that just kind of happens in a kind of binary way. And you can imagine that it's going to be useful if you don't have an arm. But how can we make these things more natural and more human? And I think it's to do with the control scheme and the interface between the human brain and the body. Because I've actually undergone surgery which remapped the nerves that went to my left hand. And they physically just like cut me open. It's a bit of a butchery kind of thing. It's a really weird procedure where they take the nerves that went to your left arm, in my case, and embed them into chest wall muscles and chop up your chest wall muscles. So now I have little segments of muscle around my body, around my chest wall, that activate when I think of using my left hand. And it's really strange for me because it's like I have 2 body parts in one place. There's sensory innovation as well, so I can feel on my chest, I can feel my thumb, my forefinger, like areas around my body. And the purpose of that is basically to give you a control system for a bionic hand. Because if you're using 2 signals to open and close these robotic kind of binary devices, it's not very natural. And as you saw in that video, I was able to do multiple different parts of the arm. I was controlling the arm with this little multiple electrode array. But still, it's progressive. You can control the speed of it by controlling these 4 sites that I have, but it's still not a great deal of control. So it seems like in this age where we have an iPhone that has a CPU in it, has 2 billion transistors in it, it's like a city in a microscopic nanometer scale. How is it that we're just building these hands that just do this, this, and this? And it comes from the need for things to be really reliable in a way. If you have a hand, you want it to do the thing that you want it to do. So the binary control gives you an assurance in a way, if you don't have a limb, that it's going to do what you want. But even then, it's not very sure. You won't find people holding their babies with their bionic limb if they have an arm, because it's like, I don't know if I'm suddenly going to let go because the muscle signal accidentally activating. So it's kind of a stressful situation. So this is kind of the next step in hardware, at least, that we have right now. And this is an arm that has 26 degrees of freedom, but it's still controlled with this TMR scheme, which is like the targeted muscle renovation. I don't know if I said that. And that was the nerve procedure. But it's a research thing, because the problem is that as much as there are a bunch of amputees that would love to have this hardware, there's still not enough of us. Obviously, there's millions of iPhones out there, Android phones as well, obviously. But, there's not enough amputees for the cost to come down. So as technology advances, people are just trying to engineer better solutions that are more cost-effective. But even the most cost-effective commercial limb is 94,000, I don't know why I put euros, but 94,000 euros for me to get an arm, an elbow, and a hand, and not even the way that it connects, which is crazy. So if we're thinking, the hardware kind of exists. There's the 26 degrees of freedom. Obviously, it's millions of pounds, but what can you do? How would we connect to these limbs in the future? What would make it better? Why, if you'd want a metal hand, surely you'd want it to at least work in the same way that your hand does already. And one of the most invasive ways to do that is to literally chop open your skull and put down an array of electrodes. They're very, very fine electrode arrays, so you can develop an image of what the brain is doing. And yeah, it literally goes over your sensory cortex and your motor cortex, which is crazy. But if you have a really limited or paralyzed body, some people are opting to try this technique. And it works effectively. In monkeys, they've done it previously, and the monkey has learned by having reinforcement of watching a robot arm move when it's got this system in, that it was able to learn to use its own arms and a third arm as well. So there's the potential to expand the human ability by interfacing with the brain. But it's risky. Nobody wants to have a plug sticking out of their head like in the Matrix, because it's going to get infected. It's going to get infected and cause you big problems. So what can we do? Something exciting from a couple of years ago is stentrodes, which actually would be the electrode array, but you'd feed it up through blood vessels in the neck and try not to be so invasive. It's still invasive because you're putting things into your brain. Hopefully these little bits of metal wouldn't start to scar up and cause you to have like a stroke or cause disruption in the flow to your blood in your brain, because that's not what you want either. And it's a limited population sample again, because there's not many people that would be willing to risk it. But imagine having a connected brain with such fidelity that you have the control to even think, not just, I want to open and close my hand, but like I want to think about just moving one finger. If you had that level of control, suddenly you'd think, maybe I should get a metal hand, because it's going to be stronger, maybe, it's going to be better. Maybe you don't even want to control a bionic hand if you're someone like you don't want to chop your limb off yet. Maybe you want to just live a life where your brain's connected. You can go up to the door in your house and just like waft it open with your thoughts, or do whatever you want. Tell the dishwasher to turn on just by thinking where the dishwasher is in your house. It would suddenly come alive. Like, there's a potential in that. And some of you probably read that Elon Musk started a couple of years ago, Neuralink, which sounds like this kind of thing. So we don't really know where it's going to go in the future. So if we have that level of control, and you wanted to chop your arm off, what would you be doing with that? Would you think, I want to have more abilities? Would you think that you have a job which requires extra strength? Would you have 2 robot arms and then lift like 200 kilos and hope your knees don't give in, I guess? But you can imagine that you'd want, like, what ability would you want? And what do you give up on the way if you think about what people face today with bionic arms is that they have an arm that does a certain task, and exceeds in some ways human bodies already, because you don't feel pain, it's made of metal, you can punch things really hard. But if a person using a bionic arm, for example, doesn't get to feel the touch of their partner or the skin of their baby, because it's just not possible right now. So would we want to integrate more with technology and feed that information into the brain is the question. And that would be really great to have sensory information. But we've had like 2 million years just on the opposable thumb of evolution, and just hundreds of millions of years getting to where we are and building this body as it is. So do we think that we can come along in like however many years technology's been really going hard, but like, do we think we can suddenly build something better than what Mother Nature has had and crafted through selective pressure and evolution? It sounds like it could be tough. And we really don't have a way to really integrate with nerves right now and feel the things through the limbs. We can get signals out, but stimulating the brain in a way it understands is actually quite difficult, although it is quite adaptive, it's adaptive, as we know, because we have monkeys that are able to use multiple arms. They're just through the visual information and like the plasticity of the brain to take in more stuff. It's like an amazing supercomputer. But will it ever be the same? Will you be able to feel someone tickling you or just like tenderly touching you if they are? It's something that you'd have to consider. And I think it's fascinating because we have this chance. I have this chance. I don't know about you guys yet, how you feel about chopping off your arm. But I have a chance to be the test bed of this technology, and so do so many people, potentially, if we continue to develop the hardware. Because if you think about it, and the future of the human race and stuff like that, if we're reaching towards a technological singularity where you'd think, we want to upload our consciousness to machines. Are we going to leave these fleshy things behind? Do we want to figure out how to get there? I think it's a good question. And if we chip in and start to make these technologies better for people, the brain-computer interface is better, then it's going to be positive for everyone. It's like really cool right now because we can build these things that allow people to live and support them in their lives and bring down the cost, because I can't get a really functional bionic arm right now, and so can't a lot of people. And greater options is only a good thing. If we find ways that we can have different abilities that different people can choose from, it diversifies the human experience. I think it just provides us with this opportunity to think about where we're going to go with the human body and what do we want to be. And at the same time, all of that energy that we put into that positively affects people's lives today, which is awesome. Thanks.